Okay, so let us get started. Let's get started. I'll start with a simple word or instruction to you. If you want to learn, you want new things, let old things be out. Okay? You know, in the Bible it says you can't put new wine in an old skin. It will burst. Huh? So it doesn't matter the age you are, it doesn't matter the stress you might go through. Let your mind be free and be willing to feed your brain with new information. So if you learned how to draw isometric, you learned how to do things the other way, do it now as if you know nothing. Then you will learn. Okay. So here we are going to do two things. This is the most critical part in designing. Now we look at it just as drawing. No, it is the key factor of designing. Okay? More especially when we come to do with these 3D drawings. This is the mother of 3D. I've taken isometric. I said how to read drawings in orthographic and isometric. In short, how to read drawing in 2D and what? 3D. This is where we have a challenge. When we are given a drawing in 2D, we find it so difficult to bring it to 3D. And when we are given in 3D, we find it so difficult to bring it to 2D. Please, I want us to make sure that we cross that bridge at all costs. We must cross it. We must crush it. Because we are the solution to the problem. You know that, eh? Yes. So you can't, when you, after finishing this program, you go to somebody, please, I don't understand how to read this drawing. You are creating problems for that person because you are the solution, not the problem. Tell yourself all the time, I'm the solution to the problem. I'm the solution to the problem. Exactly. Then you'll be solving problems. Okay, so now, we always have to start with isometric scale. I'm starting with isometric first. You start with isometric scale. I want you to pay very good attention on this isometric scale. Once you draw isometric scale, the next thing, you need to be able to draw the isometric box. Everything is in the box. You understand? Whenever you are drawing everything, when you are planning the isometric, the moment you draw the box, all the things are within the box. So you can't say my paper is small. No, the box once it's made, it means everything is within the box. So, your isometric box must always be what? Faint lines. Whenever you are drawing, before you get to the final answer, always draw your lines in what? Faint lines. Do you understand, class?
Yes, sir.
Do your lines in faint lines. The one who makes dark lines and asks me to say, Mr. Piri, I have a question. And your lines are dark, please. I'll just look at you with joy, but anger in my heart. Say, are you listening or not? So I want lines to be what? Lines to be faint. Thank you. So from now onwards, I don't want you, when I come to see your drawing is a multitude of dark lines before you even finish your work. I would love if your work is very faint. Is that clear? Okay, noise out. Now, I will erase this information so that I can draw the isometric scale here. Is that fine?
Yes, sir.
Okay. Isometric scale is paint lines. It is drawn 0 degrees, 30 degrees, 45 degrees. So 45 degrees is what? True size. True measurements maybe work well. So, whenever you are drawing the isometric scale, you need to draw a line 0 degrees, faint line. All the lines are faint and thin. Faint and what? Thin. You draw the horizontal line, then you take your set square, 30 degrees set square. Can I have the set square? You take the set square 30 degrees, have it sit on your set T square. This is your T square. Your set square sits on top of your T square. You draw 30 degrees. The horizontal you draw using your T square. Then you take your 30 degrees, you draw faint line. Then you take your 45 degrees. At the same point, you can see what I've done here. You draw 45 degrees. Is that clear? Okay. After you do that, after you have drawn the 30 degrees line and 45 degrees line, go to your 45 degrees line and mark 10 millimeters spacing all the way until maybe up to 120. It's good enough. Okay? So I'll mark 10 millimeters, 10. Mine ends at that size, it's okay. So the first 10 millimeters divided into 1 millimeters. The first 10 millimeter from the sharp point there, divided into 1 millimeters. So there will be 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, of course, the last one. Okay, then I'll number them. The first one here will be 0, 10, 20, 30, 40, 50, 60, 70. You keep going at least until 120. Are we together, class?
Yes.
Okay. After you do that, you go to your T square and you take your set square. Doesn't matter which one, but take your T square and your set square. You put like this. Here, your t square and your set square. Drop these lines 90 degrees using your 90 degree side. Drop them to 30 degrees. Drop the lines at 90 degrees. Ensure to bring the lines vertically down from 45 degrees line to 30 degrees line. Not to 0 degrees, please. To 30 degrees line. Whew. This is what you need to do. So I'll drop them. I'm using blue and red as construction line. Like that. Did I drop these lines to this line? And you go and do what you want. Okay? So, you drop these lines vertically from the 45 degrees line to 30 degrees line. Is that clear? Now, why are we creating an isometric scale? Why? For what reasons? One, when you are drawing isometric, we normally draw at 30 degrees and 90 degrees, eh? Yes. All the lines at 30 degrees that are going on the sides, you use what? 30 degrees line to take the measurements. The true measurements you get from the ruler, or you can use your 45, it's fine. Like 90 degrees is true measurement. But all the lines that are all going on the side, they are all going to be on the scale. You are using the scale. Is that clear? So if I want to draw, I've got my horizontal line, 30 degrees, 30 degrees. Okay? Then I've got 90 degrees. I want to draw a box of 100 by maybe 200 by, okay, 100 by 150 by 8 millimeters height. So, my box, this box, is 150, 100, 80. I want to draw this box. 150, 100, 80. The 100 and the 150 will be on what? Scale. So this is it on scale, 30 degrees. This is the scale, 30 degrees. This is the true measurements. Is that clear? Are we together?
Yes, sir.
So I'll come and measure 150. Now because I've got let me make it 152. There is a reason why. I'll come here. I can use the 50s because it's 150, eh?
Yes.
I'll use the 50s to transfer based on what I've measured. Now, the last 50, I need to come and count 1, 2. These two spaces here, therefore 2. Can you see? 50, I'll measure from there to there. I'll measure the 50. I'll get this length. Not here, but here. On this 30 degrees line, I want to measure 150. Come on, don't draw your own things when I'm explaining here. So I'll measure from here, from there to there. This length represent what? 50. But in the actual measurement, is it going to be 50?
No.
It will be less than 50. Maybe it will be 42 or 41. Why? Because it is a reduced size. When a line is at an incline and you're looking at it straight, it shortens in its length. Are we together?
Yes.
So it will be 50, but lesser amount. This 50 is there. This is the true size. But this 50 is a bit smaller. Is that clear? Are we together? So now I'll take this 50. I'll mark 3 times. 1, 2, 3. And I'll come and measure these 2. From the 30 degrees, then I'll come here and mark the 2. Okay, now because of this weighting here, I'll reduce this drawing. Then the 2, I'll put it there. After I've done that, I'll draw vertical line. I'll draw the vertical line. This 80 millimeters, do I need to go to the scale? I'll just take 80 millimeters straight from the ruler. Take your ruler, measure 80. Is that clear? Are you listening? Yes. Okay, you measure 80. This is 80. This one is less 150. We don't know which number, your scale will tell. So this is it. 150 from scale. 152 from scale. Then once you do that, take your set square and your 30 degrees. Remember, it was a T-square like this. Eh? Yes. Are we together? Yes. I took 30 degrees, drew that line. 30 degrees, drew that line. I didn't use the 60 or 45. I say 30 degrees. 90 degrees, you go up. The same 30 degrees, I'll come here, draw 30 degrees, draw 30 degrees. Is that clear? Yes. So, I'll draw 30 degrees, 30 degrees. I need to measure 100. When you use the scale, we are using the 250s. 100. When you use your scale, 100 becomes almost 82. So you come, you measure 100 scale. Then you draw 90 degrees line. After that, 30 degrees. And this side, 30 degrees, they meet there. I've drawn the highest point, the longest side, and the width also the biggest width. I know that the rest of the information is within what? The box. So how do I draw? If my drawing, now I modify. Oh, this is true. I'm going to the modification now. So, do we understand how to draw the box? Yes. So, this is 100 from the scale. Any question? Any question? You are 100%. Yes, sir.
When you draw this on the drawing board, do we draw the scale as well?
That is it. Without a scale on your drawing board, I won't mark your work. The first thing is, where did you get the measurement? You must show me first. So the scale is waiting, is telling me. The moment I see the scale, I'll go to the scale and give it 5 marks. Then now I'll start checking. Check your scale and check your weight if they are matching. So your scale must be on the left-hand side all the time of your paper. Is that fine? Any question?
No.
Any question there online? Any question? Yeah, perfect. Okay. Thank you. Did you?